I'm Nick, and this is a wood-burning camp stove. It's great until it rusts to the point where you can't use it anymore, like this one did.
The inside of the stove is almost rusted all the way through, and the pot supports on top, which are supposed to fold out, are seized in place. I thought about using a high-temperature coating or alloy, but coatings can chip off and special alloys are expensive, so I rebuilt the inside with ceramic instead. I used fused silica because unlike metal, it's almost impervious to water and thermal shock and cycling at high temperatures. It will sit inside a stainless steel shell, which allows air to flow under and around the fire chamber like in the original design. I made an inner and outer mold section out of sheet metal with the tools at the company I work for. Since I don't have an industrial furnace that can melt silica, slip casting was really my only option. I cut the side pieces for the outer mold on a shear and cut the remaining parts for the mold and outer shell of the stove from flat stock on a CNC plasma table. This is kind of cheating, but the focus of the project for me was the casting itself, and plasma is also kind of awesome. I rolled the sides of the molds with a slip roller. Then marked and cut the wooden dowels into pieces and inserted them into the mold parts to form the air holes in the casting. I assembled the mold pieces with duct tape to make sure they'd be easy to remove after casting. The top of the casting needed a lip so it could rest on the outer metal shell of the stove, so I rolled a flange into the mold, taped on another section with a wider diameter, and then sealed it with caulk. Finally, I marked and cut pieces of PVC pipe to make the pattern on the top of the casting to allow smoke to escape from under the pot. Sprayed all the pieces with silicone mold release. And put the two halves of the mold together. The ingredients for a fused silica ceramic are, of course, insecticide, Mrs. Meyer's pickling lime, and silica sand. I measured the ingredients out into a bucket. Added water and stirred. Then poured the slip into the mold and pressed the PVC pipe sections into the top. After the casting cured, I removed the mold. There were voids in the upper air holes caused by shrinkage, so the casting actually dried in two pieces, which means extra room for airflow, or that I probably should have just drilled the holes instead. Anyway, the last step was to fire the ceramic and melt the outer surface into a solid glass for strength. I built a kiln out of refractory brick to let it heat and cool slowly to prevent cracking. I finished the outer shell with the same tools as the mold, but used a spot welder instead of duct tape on the seam, then put the ceramic inside and lit a fire. Like the original all-metal stove, the fire was almost smokeless and burned up close to all the fuel, so besides the accidental two-part casting, this turned out alright.